Welcome. I'm Jean-Francois Mahar, your facilitator. Today, we're going to explore binary numbers and to see how you can bring that to your classroom. I will guide you step by step, share some practical examples, and then get you started right away. So let's jump right into it.
Throughout history, almost every civilization has used a decimal number system with 10 digits, 0 through 9. All of the numbers we can possibly think of use some combination of those 10 digits. Computers, however, operate very differently. Instead, they use a number system that has just 2 digits, 1 and 0. This system is called binary, and your computer uses it all the time. Computers need information in order to do what they do. This digital information, or data, is made up of something called bits. Bit is short for binary digit, meaning each bit is really just a single number, either a 1 or a 0. These bits can be combined to create larger units like bytes, megabytes, and so on that we use to measure our files. The larger a file is, the more bits it has. So something like a high-resolution video is actually made up of millions and millions and millions of ones and zeros. So how exactly do these ones and zeros come together and allow a computer to function? Let's think of binary as a light switch. Imagine that a 1 represents the light switch being on, and 0 represents it being off. With binary, the light is either on or off with no other possible states. So these bits are strung together as different combinations of 1s and 0s, and they form a kind of code. Your computer then rapidly processes this code and translates it into data, telling it what to do. You might be wondering, why do computers use binary instead of the decimal system that we use for counting things in the real world? Well, as previously mentioned, binary has 2 states, off and on. If computers were to use decimal, there would be 10 states instead. Our computers would have to work a lot harder to process all of these. Binary is easier for them to process and also takes up less space. Just like atoms make up everything around us in the real world, everything in the digital world, including video, text, pictures, and more, can be broken down into binary. And even though we can't see them, it's all a bunch of 1s and 0s.
Now that you had a chance to learn a little bit about binary, now it's time to move into our actual activity for today. Today we're going to use what's called a Flippy Do. I will be able to walk you through this step by step, but ultimately this is what we're going to end up with. On the board here, I was able to put it together so we can visually see when we do the exercise how each number corresponds to the bit, which is called binary digit, as you learned from the video as well. And sometimes it's 0 or 1, off or on, false or true. So all these are representation of the binary digits, 0s or 1. So let's get right into it.
First, we need to grab the materials: your Flippy Do template, a marker, and a pair of scissors. In addition, you need the How to Make a Flippy Do. To fill out the Flippy Do, we start with the top row with the base 2 and their corresponding index 0 to 7. On the second row, filled it with the decimal values from left to right: 1, 2, 4, 8, 16, 32, 64, and 128. On the third row, fill it with all zeros. Now we grab our pair of scissors to cut along the lines on the fourth row. Finally, flip each one and write the number 1 on the backside. Pause the video here in order to complete filling out the Flippy Do.
A little bit about Flippy Do. We just finished making one, and we made exactly one of these. As you see, the numbers on top is your zeros all the way to 7, which are your index, because we're doing base of 2. That's why you see all the 2s at the top. But the middle row is where you get your values. These are your base 10 numbers. So 1, 2, 4, 8, 16, 32, 64, and 128. So what we're going to do is we're going to go through an example here, and we're going to use our Flippy Do so we can see exactly how it works. We don't have to guess because, again, this is why we created this tool. So not just for you as educators, but as students, basically encouraging them to know that this is a very powerful tool. They do not have to guess. It will always be right for them. So let's get right into it. All right, so now let's look at some examples. Let's say, for instance, let's start with some easy numbers. Let's say we want to do the number 5. So we want decimal, which is number 5, but we want to know what our binary equivalent is, okay? So to do this, we're going to look at our table. And by default, we know that everything is set to 0. And if you remember earlier, we mentioned that when it's 0, that means everything is turned off. But to get our 5, we need to see what are the numbers that correspond, or give a combination of numbers that will give us our base 5 number. So we look at 4, because 4 is within 5. By the way, you can't do 8 because 8 is bigger than 5. So we immediately eliminate anything 8 and over. So we know 4 is 1. So I'm going to erase the 0, and put a 1. But if you notice on the Flippy Do, that's why I say we use it, I'm going to flip this and put a 1. So now it looks something like this. So we have the 1 activated. Therefore, if we do a 4, that remains to be that we have 1 that remains. So we're going to erase the 0, put a 1, and again, here you go. I flip the 1 over, so now I have a 1 on the 1 place and a 1 on the 4 place as well. So what we do is 4. Then basically what we're doing is addition, because we have a 4 plus 1 equals 5. So the equivalent binary code for 5 is 1, 0, 1, 0. I usually do mine at 4, but you can do, the whole entire 8-bit, which is what this is an 8-bit. So it's 1, 2, 3, 4, 1, 2, 3, 4, 0, 1, 0, 1, 0, 1, 0, 1. So that's the equivalent of 5. Let's try one more. Let's do 9. Okay? 9, similar to how we did 5, we're going to, let's set this to 0. Okay? So we're going to look at 9, where we know 9 is less than 16. So therefore, 16 is bigger than 9. We don't want to use 16, so we'll be out of bounds. So we know we have to go to 8. Again, I'm going to reset my Flippy Do. Change it to 1. So now 8 is active. So I'm going to write 8. Therefore, I have 1 remaining. So I flip over the 1. End up with a 1. Change this. Now we have a 9. So therefore, our binary code is 0, 0, 0, 0, 0, 1, 0, 0, 1. Okay? So that's with 1 digit, or we'll say singular digit for decimal. Now we go over to double digits. So the easiest way I'm going to do this, let's say we do the number 25. All right? 25. So let's reset our Flippy Do. Okay? So we know 25, right, goes all the way up to 32 because 32 is bigger than 25. So therefore we start with 16. So if I do 16, okay, I'm going to flip over 16. How much do I have left? Well, 25 minus 16 is 9. So the next number we can turn on is 8. So I'm going to turn on 8. Okay. Plus 8. So we need one more, which is 1. So I'm going to activate the 1. Plus 1 gives you 25. Okay, so now the code is 0, 0, 0, 1, 1, 0, 0, 1. Okay, now for practical purpose, let's do one more. Let's do 124. It's a big number. All right, so let's reset our Flippy Do. In doing so, again, let's think about it. 128 is bigger than 124, so therefore we go to the next number. So 64. I'm going to write down 64. I'm going to turn on 64. Okay. Now, if you want to do some math to the side, so 124 minus 64, that gives you 60 that's left. Okay, that gives you 60 that's left. So therefore, what's the next number? Well, there's a 32, so I'm going to turn on 32. Okay, so now we subtract 32. That will give you an 8, and that gives you 2. Okay, so now we have 28 left. Well, the next number will be what? 16. Actually, I forgot to reset all of these. So we have a 1 and a 1. Okay, then 16 is next. You do your 16. Okay, so let's see how much we have left. 16 from 28. We have 12 left, which means we can do an 8. So we're going to turn on 8. We subtract 8. That leaves us with 4. So then I turn the 8. That leaves us with 4. I turn on 4. Now we have nothing left. So this should give you 124. Okay, so now if we look at the code, it's going to be 0, 1, 1, 1, 1, 1, 1, 0, 0. So as you see, we can get really deep into this, but notice our threshold is 128. Okay, so now that we had a chance to walk through an example or a couple of examples, now we have an activity guide that we can go through. It has a table. I will go ahead and attach this to the video so you can have the activity guide, but you're going to practice this. And pretty much what happens is the first part is you're converting binary to decimal, and then you go from decimal to binary. So it's just trying to get you to practice to go back and forth. So if you have a decimal number, how to convert to a binary, and binary and vice versa, how to convert it back to a decimal. Okay?
Binary is the language of computers, and with your Flippy Do, you can decode and build any number. Keep practicing, and soon binary will feel just like second nature. Thanks for watching. If you enjoyed today's video, make sure to like, subscribe, and share it with friends or students who love exploring computer science. Until next time, keep learning and keep coding.